Namaste, welcome back to our channel Qubit Educational Services. I am Pranesh, the founder of the channel and an IISER Bangalore alumnus. In this video, we are going to discuss the physics section from IISER Aptitude Test 2024, which took place a year ago. So just after the exam, I had put 2 surveys and I have received many responses. The first one was the overall experience of the IISER Aptitude Test as far as the difficulty level is concerned. So I received around 1,000 votes, and most of you have voted that it was, say, moderate to above average, because you can see the people who said it was tough or very tough is more than the people who said it was easy or very easy. Okay, so this is typical IISER Aptitude Test level, not too difficult, not too easy, slightly above the moderate level. Okay. So as far as the overall difficulty level was concerned, there are no surprises. Okay. Now, well, after the key was released, I asked you, like, what was your score? And I received around 730 votes here. And here also, well, I don't see much variation. I think the scores will rise a bit considering the number of candidates, but no official record is available for that. Considering this survey, almost 64% of students, their score was less than 100, and then a quarter of them had their score in the range 101 to 140. So I think for this year's admission process, the minimum score would be somewhere around 130. Okay, as in if you are in that range 130 to 140, you're almost guaranteed a seat in well, at least one IISER. Okay, now again, that is an estimate because we currently don't have the rank data. Okay, we cannot compare it with the previous year's cutoff ranks. Remember, the ranks always matter. Okay, the score matters less, rank matters the most, rather rank only matter. Okay, all right, and there are a few students who said their score is above 210. That's a very good score, and some of them have their score in the range 180 to 210. Before we discuss our IISER Aptitude Test 2024 question paper, let me tell you a few things about IISER Aptitude Test 2025. So as you might be knowing, we have already launched CDP, Concepts Development Program, which is specifically aimed at the IISER Aptitude Test. So the main objectives of this program are: we help you in understanding the concepts thoroughly. Because although we say that IISER Aptitude Test is not too difficult as JEE Advanced, it's not also formula based or something which you can crack by just mugging up. Okay, the thorough understanding of the concepts is necessary, and this will also be useful to you in your further education and research. So we help you in building, understanding the concepts thoroughly. And second thing is we help you in solving problems of varying difficulties. Again, this is a typical feature of the IISER Aptitude Test. Some questions are very easy, some questions are moderate, and some questions are, well, they make you think. So exposing you to all possibilities in terms of difficulty puts you in a much better position to answer IIT level questions. Now, while solving these MCQs or these questions, we come to know some strategies, okay, some patterns that you might see in the IISER Aptitude Test PYQs, or a few things from, let's say, first or second year after your 12th that might be required to you in solving some problems, particularly in differential equations or complex numbers. We also help you in we also help you in, well, learning those things and applying them in problems. And last but most important feature is we give personal attention to each and every student who has enrolled in the CDP, making sure that all 3 points that we discussed before are being taken care of. Okay, now the courses, the subjects that we are offering: physics and maths, which are closely related to each other, as you might know. And well, there is a question in physics section which we will discuss now, which is actually a purely mathematical problem. Okay, so both physics and maths will be covered by me, and biology will be covered by Dr. Tejaswini Kulkarni. All our sessions will be live and in the online mode. We will share the class notes. We will give you MCQs for practice. Okay, we will also help you in solving the previous year's questions. And all our sessions will be recorded and the recordings will be made available to you till your exams. All right. Okay, the other key feature in any preparation program is the tests. Okay, because I've seen students doing extremely well in the theory classes, but when it comes to the test environment, okay, because of the pressure, they are unable to recall and they often blank out. Now to help you come out of that mindset, we conduct topic-wise tests which happen usually on Saturdays. We also conduct cumulative syllabus based tests, like that is the syllabus which has been covered till that day at the month end. Those tests will be monthly, and once the entire syllabus is completed, we conduct full length tests which will be based on the entire syllabus. Now we're also offering group discounts. The total fees are 29,999 only per student. But if, let's say, 3 of you enroll together and confirm your admission, then each one of you is going to get a 10% discount. So to enroll, you can mail me on qubitclasses@gmail.com, or you can also mail me on praneshm@alum.iisc.ac.in. Now, the first key slide of the video. Key features of IIT 2024 physics. First, the dominant section was mechanics. Okay, so there were a lot of questions. On oscillations. Considering that physics overall questions number is 15, 3 of them were based on oscillations and 2 of them were based on circular motions. Okay, now a surprise for all of us, there was no question on gravitation. Well, pure gravitation, let's say satellites, planetary motion, escape velocity, variation of g with latitude, longitude. Okay, no question on gravitation. There is also no question on units and dimensions. Previously, there has always been one question on either units, dimensions or errors. Okay, or expressing some quantity in dimensions of some other quantities or fundamental constants. There was no such question, and also no question on semiconductors, diode and rectifier stuff. Another key feature is that there was a problem, okay, in which the particle was traveling along a straight line. Its displacement was given, okay, and I think it was cube of sine and square of cos, or the other way. Now it was asked to find the period of that particular motion, and this is a very standard exercise in functions. Now if you were a PCB student, then you might have faced some difficulty in solving this particular problem. Of course, if your basics are clear, of course you could have solved it, but that problem should have actually been in the mathematics section rather than physics, because it was a purely mathematical problem. Acha, now let's discuss one by one all the questions. So first 5 and the 7th. So this sequence is according to the answer key that is available on their official website. Okay. Question 1 was based on uniform circular motion. There were 2 cyclists, okay, which were traveling in the opposite direction, one with uniform speed, the other one with constant acceleration, and we were asked to find what was the distance, what were the distances traveled by both of them. Okay, pretty simple question it was. You had to make use of uniformly accelerated motion there, and secondly uniform velocity motion. When we solve each of these questions in detail, you will also understand the procedure to solve the problem. Question 2. Now this was the first question on oscillations. Okay, this was the first question on oscillations, and of course angular momentum. This has been a very common topic, right, in all of the previous versions of IISER Aptitude tests. Questions in which they ask you to calculate the angular momentum, they have been very common. So in this second question, okay, we had given a simple pendulum and it was also given that it performs SHM, and we were asked to compute the relation between the amplitude of angular momentum, okay, amplitude of angular momentum and the period. So the power was asked here, to which power of time period is your angular momentum proportional. Question 3 was based on Atwood machine, again a mechanics problem. Okay, so here we had to make use of the free body diagram, and one key feature is that usually we ignore the mass of the pulley and therefore its inertia. Okay, both translational and rotational inertia, but in this case we were required to consider that. Okay, we were required to consider that because we were asked to find the angular acceleration of the pulley. Okay, so we had to draw the free body diagrams of the m/2 mass m as well as the pulley. Okay. Next, question 4 was a classic IIT level problem according to me, because it made use of two concepts or concepts from two different chapters. One, of course, vertical circular motion, VCM, and the second thing is from mechanical properties of fluids, that is buoyancy. So this whole setup of vertical circular motion was kept in water environment. Okay, so the additional forces or additional force that we are required to consider while drawing the free body diagrams at A and at C was buoyancy. Okay, and accordingly the equations change, and work energy principle was supposed to be applied there. Okay, because in addition to gravity, buoyancy also does some work while the ball moves from the bottom to the top. Okay, fine, but I think it was a fairly simple question. If you haven't considered the work done by the buoyant force when it goes from A to C, you may not have got the correct answer. Acha. Now question 5 is typical SHM problem. Okay, although we don't have spring mass system here, okay, it's actually again a buoyancy based problem. If you read it, you will realize it. Okay, so there is a sphere which floats on water. Okay, there's a sphere which floats on water, which is half submerged, and its top end is slightly pushed onwards, and then it performs oscillations, and we are supposed to find the time period of the oscillation. Okay, now because they have said that it executes SHM, we had to make some approximations in arriving at the differential equation of SHM, basically obtaining mx double dot plus kx equal to 0 equation. Okay. So in that, while approximating, we had to consider a small disc-like portion of the sphere which gets submerged in water, and because of the buoyant force acting on it, well, that is the restoring force. Okay. Alright, so these 5 questions were on mechanics. Then a thermodynamics question based on first law of thermodynamics, delta U is equal to Q minus W. Okay. Now this was a bit confusing because they had said no external work was done, so W is 0. Okay. But they had also said that the gas expands adiabatically. Okay. Now adiabatically means Q is equal to 0. Okay, so combining these two things, we had to solve question number 6, and it's based on the concept of the process of free expansion. Okay, fine. Question 7 was based on mechanics, the third question on oscillation. So first question, second, and this is the third question. Now I said oscillations because the motion is periodic, okay, and it is rectilinear along the x-axis. Now this is the pure math problem, okay, and we always consider the larger of the periods, fundamental periods of the two functions, which themselves are periodic. So it was sine squared omega t and cos cubed omega t. And for students who have maths, okay, who are not PCB students, for them this is a standard exercise, right? For sine theta the period is 2 pi, if you square it the period becomes pi. For cos theta the period is 2 pi, so for cos cube also the period is 2 pi, right? And if we have a function, let's say cos theta, whose period is 2 pi. For cos k theta, the period becomes 2 pi by k, right? Question number 8 was based on mean free path kinetic theory and the concept of specific heats from thermal properties of matter. So you can say mixed concepts, but essentially all of them belong to thermodynamics only. Okay. Now this question, it was formula based. Okay, this was a formula based question. The reason being, you had to know the formula for mean free path, or at least its variation with the diameter of the molecules, the number density or the total number, and the volume. So where do those terms lie, okay, in the expression for the mean free path? Accordingly, you had to find, or you had to choose the correct option. For specific heat, okay, the same ideal gas, you can assume the same specific heat C and say that heat gained by one portion will be equal to heat lost by the other portion, okay, until the equilibrium temperature is achieved. Okay. Acha, so this was mechanics, thermodynamics, okay, subjects related to mechanical engineering. Now let's go to electromagnetism and modern physics and optics. So compared to mechanics, the proportion for electromagnetism was slightly less this time. Okay, there were only 4 questions from electromagnetism. Okay, there were 4 questions from electromagnetism. First one was from electrostatics. It was based on Coulomb's law and superposition of electric field or forces. Okay, superposition of forces. We had to basically find the acceleration on this charge at t equal to 0. So to do that, we had to first find the force of attraction between these two, force of attraction between these two, and then you had to add them vectorially and get the answer. Also some amount of vectors is involved, but not too heavy, simple I cap j cap things. Okay. Question number 10 was based on AC circuits or alternating current, and it was given that both the resistors A and B have the same resistance. Okay, the thing is there is a particular frequency omega of this alternator, okay, and certain initial charge in the capacitor. So capacitor is not initially uncharged. Okay, the current is in phase with the source. Okay, so the phase difference between the current here and the voltage is 0. Okay, so current is also, say, amplitude sin omega, and then accordingly I had to find the expression for omega or value of omega. That was question 10. Question 11 was also very easy. Okay, we were given a loop which is not planar. Okay, it's like, let's say this is the floor and then this is the adjacent wall of the room. There was a loop, so all you had to do was imagine a current flowing in this direction for this wall loop, and imagine a current flowing through this in this direction for the floor loop, and you have to vectorially add, essentially superposition, you have to vectorially add the magnetic moments due to these two loops, and then you'll get the answer. Okay, in fact, if you look at the options also have vector representations. Okay, pretty simple question. Acha, the last question from electromagnetism was on current electricity. Now typically when we discuss current electricity, we don't discuss the DC circuits with capacitors. Okay, we only consider the Kirchhoff's loop rule or voltage rule, but there only resistors are involved. The network of resistors is there. Okay, but in engineering entrances in particular, the problems on DC circuits with capacitors are very common. So this is also no exception. Okay, so firstly, this capacitor C1 gets charged due to this battery of potential difference, let's say P, and then this battery was taken out of the circuit and capacitor C2 was brought in. See, the conceptual understanding always helps. So here we had to use the fact that as long as the capacitor C1 has a different voltage than capacitor C2, it will continue to get discharged and C2 will continue to charge. Okay, so a moment will come where the potential of C2 becomes equal to potential of C1, and that is at that moment the charging or discharging will stop. Okay, so we had to basically find this ratio Q2 upon Q1 plus Q2 once the charging and discharging stops. Okay, so when we solve this problem, we'll see the working. It's actually also very simple. 13th question based on nuclei, nuclear binding energy and mass effect. This was rather the only question where there was some scope of using calculator. Okay, there was some scope of using calculator. Again, according to me, it is a very simple problem. You have to basically find the difference between binding energies of two isotopes of oxygen. Okay, one containing 2 extra neutrons. Question 14 based on ray optics and lateral shift. Okay, in this problem, of course, we know because of the involvement of Snell's law, we have to use trigonometry. Sin I upon sin R is equal to n. But additionally, because in this problem we are required to find the lateral shift. Okay, and in fact we have to, we know that the lateral shift is 0. We are given that, and we have to find the refractive index. Sorry, not refractive index. Sorry, the thickness in centimeters of the lower slab. This was asked. Okay, a pure trigonometry based problem. Okay, well, once you use Snell's law and apply the condition that the lateral shift is actually 0, okay, you will eventually understand what we are talking about. Okay, something like this. So this is the emergent ray, outgoing ray, the emergent ray. Okay, so this will become the angle of emergence, and this is the first angle of incidence. All right. Also, interestingly, there was no problem on prism. Okay, there was usually when it comes to ray optics, it is either lenses, mirrors, or prisms. But this is, I think, for the first time they gave you a problem on just slabs. Okay, so no mirror equation, no thin lens formula, no lens maker's equation, no telescopes, no microscopes. Okay, last one. Simple, again simple. Dual nature of radiation and matter, dual nature of matter actually, photoelectric effect. So we have to use the photoelectric equation and get the expression for the work function. Okay, again we know that because photoelectric equation represents a straight line, it again became a problem on 2D coordinate geometry. Fine. So in my opinion, okay, in my opinion, again some questions were very straightforward. Okay, some questions were a bit lengthy, but I would say doable, like this slab problem. Okay, and some of them were slightly more involved. Let's say this AC circuit problem, and yeah, this problem was also not too difficult, but once you understand what is basically causing the restoring action, and if you use the correct approximation, the answer will come in maximum 2 or 3 minutes. Yeah, in this problem, applying the work energy principle correctly is fundamentally or is essentially there. Okay, if you don't do it, then you'll not get the correct answer. Same thing here. Also here, based on concepts, this is easy. Okay, so we have successfully completed our discussion on all the 15 questions on IISER Aptitude Test 2024 Physics. Thank you, and I will be uploading the detailed solutions of both mathematics and physics very soon. Please subscribe to our channel for more interesting videos related to IIT as well as NEST. All the best.